Now we discuss about the p block elements. So what are the p block elements? Generally in that periodic table, left side it is with the s block elements and right side it is with the p block elements. So in this p block elements, generally third A to 0 group elements. Total 6 groups are there. Okay, the 6 groups are comes under the p block. So in this p block means here the differentiating electron. What is mean of the differentiating? The last electron is known as a differentiating electron. So the differentiating electron, it enters into the p subshell. So that elements are known as a p block elements. For example, here the electron it is enters into the 1s2, 2s2, 2p5. Okay, the last electron is enters into the 2p5 na. 1, 2, 3, 4, 5. So here it is 9 means it is the fluorine atom. Means fluorine atom it comes under the p block elements. Okay, differentiating electrons enters into the p subsets. It is known as the p block elements. So now we discuss about that p block elements. So in that p block elements here, first we discuss about the boron hydrogen compounds. So what are the boron hydrogen compounds? Here boron and hydrogen they combine, it forms that compounds that is known as a boron hydrogen compounds. So here diboron, it is a one of the boron compound. Okay, so here generally this diboron, its formula is B2H6. Generally here it is just similar to C2H6 na. Here it is with 2 boron atoms and here it is with 2 carbon atoms, and here it is the 6 hydrogen atoms and here also 6 hydrogen atom. Means here it just similar to B2H6 and C2H6, but here the number of electrons are different. Okay, here in the C2H6 it is with total 14 electrons and here it is with only 12 electrons. Means here it is the electron deficient molecule. Due to that electron deficiency, here it shows the less number of the electrons than compared to the C2H6. So generally this diboron, it is highly reactive and toxic compound, and here it is prepared by using that boranes. Boranes they undergoes the dimerization, it forms the diboron. Okay. Now here we see the structure of the diboron. It is very important, structure of the diboron. So formula is the B2H6. Means here it is with 2 boron atoms are there. It is the 2 boron atoms. It is attached with this boron and 2 hydrogens, and here also it is with 2 hydrogen atoms. And here the remaining 2 hydrogens are here. Okay, see 1, 2 boron, and how many hydrogens are there? 1, 2, 3, 4, 5, 6. So it is the structure of the B2H6. So in this structure here we see the how many borons are there? 2 borons are there. Okay, in which here it is with 4 terminal hydrogens. Okay, these are known as a terminal hydrogens. Terminal means end. Here how many terminal hydrogens are there? 4 terminal hydrogens are there, and here we see the 1, 2 BHB bonds are there. Okay, here it is BHB bond and here it is a BHB bonds. So here generally here total how many elements are there? 3 elements are there na. Here these 2 borons, okay, is attached with the hydrogen. Means total how many are there? 2 borons and 1 hydrogen, means 3 elements are there. But here electrons are only 2, means here the 2 electrons are ready to share the 3 elements. So that's why here it shows the banana shape or tau shape of the bond. Okay, that's why it is also known as a banana bond or tau bond. These 2 hydrogen atoms in this B2H6, there is no any direct link of the 2 boron atoms. Okay, so here this hydrogen it acts as a bridge in between these 2 boron atoms. So here this shape is known as a banana shape or tau shape. So these diboranes, these are heated at high temperatures. It forms the higher boranes. Okay. So in that higher boranes here, the important, first we see B4H10 molecules. We see the structure of the B4H10 molecule. How many borons are there? 4 borons. 4 borons are there. Okay, it is with hydrogens. And here one more hydrogen. And here one more hydrogen. It is the structure of the B4H10 molecule. It is a one of the higher borane. Okay. So this B4H10 means it is a tetraborane in which it is just like a butterfly structure. So in this high boranes here, calculation of total number of electrons and syntax number, it is very important. Okay. Syntax number. Okay, the syntax number is explained based on the bonds present in that molecule. Okay, here S stands for BHB bond. And here Y stands for BBB bond. Means 3 boron atoms are directly linked. Okay, so that is known as a BB bond, that is a Y. And T means it is with 2 boron atoms linkage. And next one is the X. X is the number of BH2 groups. Okay, S stands for BHB bond, Y stands for BBB bond, and T stands for BB bond, and X stands for number of BH2 groups. Okay, now we calculate that syntax number and total number of electrons in this B4H10 molecule. In BHB bond, how many BHB are there? See here, it is the 1 and here it is the 2, it is the 3, here it is the 4. So total how many BHB bonds are there here? 4 BHB bonds are there. Okay, and next BBB. Okay, here 3 boron atoms are bonded here in this structure? No. So here it is 0. And BB bonds. How many BB bonds are there here? 1 is there. Okay, so 1. And BH2 groups. See here, it is the 1 BH2 group and here it is the another BH2. Total how many are there BH2 groups? 2. So here its syntax number is 4012. Okay, so how to calculate that number of electrons? Simple. Here each one it is with 2 electrons now. So here it is with 2 electrons. It is 2 electrons, 2 electrons and 2. So means it is 8. Here it is the 0 and here it is the 2 and here it is the 14. So total how many here? 14 electrons. Okay, in this B4H10 molecule, its syntax number is 4012 and here the total number of electrons are the 14 electrons. Okay, the syntax and total number of electrons, it is important. Next example, B5H9 molecule. It is the pentaborane, it is with pseudo electrons. Okay, here it is with total how many? 5 borons are there now? 1, 2, 3, 4, 5. Okay, 5 borons are there. Okay, in which 3 borons are directly bonded here. And here in between these 2, here it is with 1 hydrogen and here also it is with 1 hydrogen and here also it is with 1 hydrogen and here also it is with 1 hydrogen. Okay, and here each boron, okay, it is with 1 terminal hydrogens. Okay, it is the structure of the B5H9 molecule. See how many borons are there? 1, 2, 3, 4, 5. And how many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it is the B5H9 molecule. So now you go to calculate the syntax number. So here how many BHB bonds are there? BHB bonds are 1, 2, 3, 4 BHB bonds are there. And next BBB bonds. How many are there here? 1 BB bond is there na? 1. And here it is 1 BB bond and here it is the 1 BB bond. Okay. So it is the weak bond. It is not considered. Okay. Here 1, 2. So total how many BB bonds are there here? 2. And BH2 groups are 0. So what is its syntax number? 4, 1, 2, 0 is the syntax number. So total how many electrons are there here? It is the 8 electrons and here 2 electrons and it is with 4 electrons. It is 0. Means total here it is with 14 electrons are possible in that B5H9 molecule. Okay. Syntax number is 4120 and total number of electrons are the 14. Okay. Next we go to the another one, that is the B5H10. Okay. In this B5H10 here its syntax number is 3202. Okay, 3202 means how many electrons are possible here? So here it is the 6, here it is the 4 and here it is the 0 and here it is the 4. Means total how many are possible? 10, 14 electrons. And next we go to the another, that is the B6H10. In this B6H10 that syntax number is the, so here that BHB bonds are, how many are possible here? 4 and BB bonds are 2 possible. And next this BB bonds are also 2 possible and BH2 groups are absent in this molecule. So total how many electrons are there? 8, 4, 4. Means how many? 8 plus 4. Here it is with 16 electrons. Next we see the last one, that is the B10H14. Okay, in this B10H14 that syntax number in which that BHB bonds are 6 are possible and BB bonds are 4 possible and BB bonds are 2 possible and in which there is no any BH2 groups. So then here syntax number is the 6420 and total how many electrons are possible here? It is 2. Means here it is the 12, 8 and 4. Total how many electrons here? 24 electrons are possible. So all these B4H10, B5H9 and B5H10, B6H10, B10H4, all these are the higher boranes. So how to form this higher boranes? Diborane, it is undergoes the reaction at high temperature. That diborane it is converted to the higher borane. Okay, in this higher borane that syntax number and number of electrons are important. Okay, in that syntax number, S stands for BHB bonds. Okay, Y stands for BB bonds and T stands for BB bonds and X stands for BH2 groups. It is about the diborane. And next one is the BX3 molecules acts as a Lewis acid. Now we discuss about that one. Okay. So first of all, what is Lewis acid? Lewis acid means electron acceptors is known as a Lewis acid. Okay. Lewis acid means electron acceptor. Electron acceptors are known as a Lewis acid. So this BX3 molecule, this boron, it is with incomplete octet configuration and also it is with empty p orbitals. Okay, due to these two reasons here, it acts as a deficient molecule. It is the electron deficient molecule. Okay. So that boron here it is with incomplete octet, means their outermost shell it doesn't have the 8 electrons and another one is in which that empty p orbitals, okay, that p orbitals are also empty. So due to these two reasons here, that boron atom is considered as an electron deficient molecule. So how to explain that? It is explained by p pi p pi p pi p pi backbone bonding. It explains the extent of that Lewis acids. So first here we see the order of the acid strength. Okay, here central atom is boron. Now we take the boron. Okay, here H stands for halogens. Okay, trihalogens BF3, Cl3, BBr3 and I3. Okay, fluorine, chlorine, bromine and iodines are combined with the boron atoms. So in which it is the order of that acidity in that BX3 molecule. So here it is the strong acid. It is with more acidic nature compared to this BF3 molecules. So here in this BX3 molecule, here boron, it shows the sp2 hybridization, and here it is with, already we know two conditions in which one is the incomplete octet and also it is with empty p orbitals. Okay, here due to this here it shows the electron deficiency. We go down the group, see here fluorine, chlorine, bromine, iodine. Okay, here we go down the group, here size of the atom is increases. Okay, size of atom is increases. So here size of the atom is increases. At that time here the extent of the overlap it is decreases. So that overlapping capacity is decreases. At that time automatically here its acidic strength is increases. Okay, that's why here this Bi3 molecule is more acidic than compared to this BF3 molecule. Okay. And next we see the boron and nitrogen compounds. Okay, boron nitrogen compounds means here we discuss about the borazine and nitroborane, that is the BN molecule. Okay, here this borazine, it is a volatile liquid, and here due to its properties here, it is the borazine, it is also known as a inorganic benzene. Okay, its molecular formula is B3N3H6 is the formula of the borazine. Okay, borazine, it is also known as an inorganic benzene. Here, its formula is B3N3H6. So, this nitroborane or borane nitride here, it is a solid and rigid structure. So, due to that here, it is also known as a inorganic graphite. Okay, borazine, it is known as inorganic benzene and boronitride is known as a inorganic graphite. So, first here we discuss about the borazine. So, that borazine formula is the B3N3H6. So, in this borazine here, that boron and nitrogen atoms, okay, here we consider the boron and nitrogen atoms. In between that boron and nitrogen, it is with two atoms are with more electronegativity differences. So, due to that electronegativity differences, here this borazine, it shows the polar in nature, and here its structure is simple to benzene. Okay, it is related to benzene. So, see the structure of the B3N3H6, boron, nitrogen, here it is with the nitrogen and here it is with the boron. And how many hydrogens are there? 6 hydrogens. Na? Each boron and each nitrogen, it is with the 1 hydrogen. And here it is with alternative double bonds. So, it is the structure of the borazine, that is the B3N3H6. So, here in which Here these nitrogens are with lone pair of electrons. Okay, here it is with lone pair of electrons. So these lone pair of electrons are ready to overlap with the adjacent atom of the boron. And here total how many sigma and pi bonds are there here? Total 12 sigma bonds are there. See here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many sigma bonds are there? All these are the sigma bonds. Okay. 12 sigma bonds or sigma electrons are there. And how many pi are there here? It is the 1 pi electron, and here it is the second pi, and here it is the third pi bond. Okay. So total how many pi bonds are there? 3. Okay. In this borazine, it is with 12 sigma bonds and 3 pi bonds there. Okay. So it is the borazine. Borazine is also known as a inorganic benzene.